Word. Whatever. Okay, quick straw poll. Developers in the house, please stand up. Okay. Who has a DevOps department? Who talks to the DevOps department? Hey. Okay, cool. Right. So my name's Tim. Hello. I work for Magentis. Our motto is we want to help people deliver stuff faster and better. So in the spirit of asking hard questions, what do I mean by deliver? What do I mean by faster? And what do I mean by better? What? Stuff, whatever. So we want to help people to get new features into production as fast as possible in a reliable, repeatable way with confidence. And obviously we could go down the rabbit hole of what do each of those mean. So we've helped people deliver software using BDD for quite a while. But we found when we're actually delivering software that that's only like part of the puzzle. Because in order to do BDD and deliver stuff, deliver software effectively, at some point you need to put it somewhere. Hence, I do DevOps, I think. So before I start, I'd like to look back at where we've come from in sort of the software development community. So the evolution of software development has taken us from sort of waterfall, as in we might build the thing eventually, to Agile, XP, and TDD. So that will hopefully help us build the thing right. Through to BDD, which hopefully we're going to start building the right thing. And at the same time, we've evolved the way in which we develop the software itself. So we've gone from like sort of manual builds over here, works on my machine. We're doing continuous builds, continuous integration, and continuous delivery. So the idea should be that at any point we have releasable software. So that means that we can deliver stuff faster. And obviously we're doing high levels of automation, automated testing, all that good stuff. Yay. But there's sort of a missing piece in that CI pipeline in terms of, well, where does it go? How do we deploy stuff? Where do we put it? And sort of in the past, sort of operations was like over here, and they were sort of left behind because you ended up with like manual error-prone configuration that sort of works on my machine, but on that machine over there. So you end up with what's called snowflake servers. So every server is different. You also can sometimes have things called leper servers, which is, I don't really want to touch it because bits might fall off. And you then also had things like the gatekeepers where it would take weeks or months to actually get some software out. Get a new server. But then something magical happened. So August 2006, 10 years ago, Amazon released EC2. I know, it's weird, isn't it? So, well, what did that mean? Well, so that meant it led to a shift in how we could think about deployment. So traditionally we had to think about, okay, how much capacity we're going to need, how big do the servers need to be, how many do we need? And again, we go back to the infrastructure gatekeepers and someone who's holding a magic wad of money somewhere. Now with cloud, we had limitless capacity. You can, if you need it, you just build more. If you need a bigger one, just put a bigger one in. So you can have what's called disposable infrastructure now. Rather than don't treat your servers like cattle, not cats. Put a bullet in them quick. It gives you a freedom to change. So that put pressure on the operations team to deliver faster stuff for the developers who needed it. So that meant we got DevOps. So I like this quote from Keith Morris, who wrote Infrastructure as Code. So what's DevOps? So DevOps is building solutions to problems that are proven through implementing, testing, and measuring. So I quite like that quote. So I sort of sum it up as you build it, you run it. But going back to, I think it's been sort of an ongoing theme throughout the last couple of days that if you're going to talk about experimentation, you're going to test something, you're going to measure it, you're going to prove it. It's all about assumptions, all about experimentation. But there's a missing piece in that, there's a missing piece in that quote. It's the discussion and the collaboration between the developer and operations. It's called DevOps. So I think the core part of that is treating infrastructure as code. You can configure it. So that means that the developers get operational responsibilities for managing the operational system, and focusing on the design and the software lifecycle means sysadmins can then think at higher levels of abstraction. But code without tests is bad. Because there's a bit here that we have to test it. And at some point, you're going to test your code. But don't we already have tests? We've got our BDD scenarios, we've got end-to-end tests, we've got smoke tests. So we've already got our tests for our infrastructure, because if the infrastructure doesn't work, our tests are going to fail. But if a test fails, how do we know where it was? So was it the functionality that broke? Was it the deployment itself broke, just one of the servers didn't come up? Was it the configuration was wrong? It goes back to there was a lightning talk yesterday about bug triage and value. If you can hunt the value, or if you can pinpoint the problem quicker, it makes it a lot easier. So we've got monitoring as well. So why do I need to test the infrastructure? I've got monitoring to check whether it goes wrong or not. So we're duplicating effort in that point. Well, I think monitoring is essential. I think you want to do monitoring as soon as possible. So that's a whole different talk. That's monitoring-driven infrastructure. But monitoring is also actually quite hard, and you get a hell lot of data. So what I think is you need to have a process where you can help design the infrastructure. So if we want to write tests, how do we know what tests we're going to write? We need a conversation. So we do BDD, we do DevOps. We do example mapping loads. So I'm not going to go into what example mapping is, because I think it's sort of been covered. If people don't know what example mapping is, read that blog. It's great. We've even got some things up at the back. So we use example mapping to create a shared understanding for our software. Can we use the same techniques to apply it to infrastructure? Yes. But we take a slightly different look on it. So instead of features, we think about context. So why context? So I think of it as you're looking at different faces of the same problem. You want to look at it from different angles and see how the whole picture fits together. So I look at the infrastructure or a specific piece of the infrastructure as a whole. How does it all fit together? So context, give me an example. So when I think about context, where are the tests going to be running from? So I'm going to have a web server. I've decided we're going to have a web server. Okay, if you're logged into the web server, what's on there? Might be doing containers. Who uses Docker? Might be logged into one of my Docker containers. What's going on in there? I might be connecting as external. I might be logged in as a user. Like, what's a user-facing view of the system? Or maybe I'm on some internal network. What are my rules or categories? So again, same sort of technique as for BDD, but I've got a slightly different focus. I'm thinking about things like, what's the behavior of this operating system or the behavior of that server? So here's a key one for me. What are the routing rules? Where can I get to? Where can I get from? Who can't get into me? What users are installed on that particular server? What applications or services are they running on it? So give me some examples. So how does a server behave, and how do those bits fit together? So as an example, okay, I'm going to have a database. It's going to be called DB01, so that should be accessible on port 3306. That's MySQL, by the way. So that shows that in the context of my web server, I should be able to connect to my database server, so on and so forth. So in the same way that you'll get questions coming out when you're talking about your BDD scenarios, you're going to get the same sort of questions when you're doing an example mapping for your infrastructure. So I like to go down the little rabbit hole. If I'm going to do SSL, okay, so where's the SSL going to stop? Is it stopping at the web server? Do I have some sort of proxy in front of it? Is it SSL all the way down? SSL all the way down? Okay. Are we using the same certificate, different certificates? Blah, 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 blah. So if you put it all together, again, example mapping gives you a great visual picture of what your software is going to look like. Gives you a good visual picture of what your infrastructure is going to start to look like. And so in Matt's blog post, there's a picture there that says, well, who should attend? So developers, ops, well, I think so. It is called DevOps for a reason. But I think things like security, testing, all those sorts of things, because they're all going to have interesting questions here. So the security guys are going to come on and, okay, well, what version of SSL? Because SSL version 1 is vulnerable to blah, 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 blah. So that's cool. So how do we actually do it? So we, and by we, I mean Magentis, we use a tool called Serverspec. It's open source. It's built on RSpec, which is a Ruby specification by example tool. And I've sort of put it here, because the way I see it is that your Serverspec tests are going to end up either being at the low unit level tests or integration tests, routing rules between different infrastructure. And it's got various cool facilities. So it just talks about like being able to, you can SSH into a machine if you configure it up. You can do things like you can build and run your Docker containers and work out what's going on in there. So it creates a nice fluent API. So hopefully everyone, so Sharon said it yesterday, testers or everyone should be able to read code. Hopefully there is going to be code and hopefully you can read it. Can you read that at the back, as in can you see the text? Can you read what it's supposed to do? Cool. So it's a slightly different take on something like Gherkin, which is the given when then scenarios. This is doing a specification. So my specification is, if I'm logged into the application server, then I want to describe what the inbound, outbound rules of the system are. So then, well, a bit more description. I want internet connectivity enabled. And actually, all that stuff, that was all sort of RSpec. The cool, interesting bits for Serverspec is when I talk about host. Host, www.google.com.au, it should be resolvable, it should be reachable. So, open source, Magentis, we've added a couple of bits to Serverspec, or specifically Serverspec AWS, so there's an AWS plugin into it, so you can describe your AWS environment. I can talk about VPCs and stuff like that. It's quite cool. Scary demo time. Okay, I want to give you a demo. So I did a quick example mapping session on the right. So I want to do a quick Hello World web page. So that means I'm going to need some sort of web server. So if I'm logged onto the web server, then Apache should be installed on it. Apache is a web server. I want it to run on port 8080. And I want some routing rules. I want to be able to get out to the internet. From an implementation point of view, I want to use Docker. And obviously, that's going to need to live on my web server. My web server is going to be my local machine. OK, does everyone know what Docker is? Or anyone doesn't know what Docker is? Cool, awesome. Right. Does magic happen? Is that the right one? Cool. So, TDD, or Test Driven Infrastructure. So, I've created a Serverspec test for my web server example. So, stuff at the back end says I'm logging onto my local machine, because that's my web server. So, I want to describe my app. So, it should be running in a Docker container called my app. Port 8080 should be listening, one of the green cards. And I want to curl, if I curl that thing, hello CukeUp. So I want to add a separate little smoke test in here to check that is the Docker container actually running and is it running my code. Thing at the bottom, I want to check that I've got internet connectivity. Can I get to Google? talk amongst yourselves. Cool, it failed. Ooh, boo. Right, okay. So, test-driven infrastructure. That's my acceptance test. I need to write a Docker container because I haven't written it. So, sorry? No, it's okay. I will need to pull that up. Oh, okay. I'm going to have to hide that one because demo fail. But what I can do is I can hide the magic, the developer magic. So I want to do sort of unit testy type thing, because I'm going to build a Docker container, so I want to check what's inside it. So magic at the top means I want to actually build a Docker container. So I have, for the developers, I've got a Docker file in my current directory. I want to describe the installed apps on it. So I should have Apache HTTPD. It should be running, and I've got my index file, which should be copied into the correct location, so it will be displayed when it runs up. So, awesome. Thank you very much. That wasn't supposed to do that. I know why. That's the problem with testing before you do a presentation and forget to set it back. Right. Ignore that one, because that didn't happen. I hadn't written that bit yet. Okay. So, fail. Okay, right. So now I need to implement it. Now I need to install Apache and all that sort of jazz. It takes ages to set up a server. Boom. Cool. Okay, that was quick. Right, so I've got my unit testing, gone around the loop. Is my acceptance test passing yet? No, my acceptance test isn't passing yet because I've not written the infrastructure to deploy and set up my application. So I need to do that. Here's something I did a little earlier. Magic happens. So all that's doing is starting a Docker container. In the real world, I'd probably spin that up on some disposable infrastructure and then put a bullet in it soon afterwards. Huzzah! I need a fist bump. Cool. So that's a quick demo, very, very simple. Obviously, you can go into a lot more detail and a lot more complex testing. So what things can go wrong? Well, so you can write reflective tests. So what I mean by reflective tests is you test exactly the same thing that you just wrote in your configuration. So if you do a Google for like sort of Serverspec examples, there's a really good bad example which talks about, I want to set up my firewall rules. And it does it by telling you what the output of the firewall rules thing is, which to me is a bit pointless because I've just written that in my configuration. And two, I can't read what the hell it's talking about. And three, it makes refactoring really hard because what if actually rather than using a firewall on a machine, I'm actually going to use something like AWS and security groups and all that sort of jazz. So reflective tests are bad. You can create unbalanced tests, so you can create your testing cupcake. So giving you slow feedback, brittle tests. So in that case, you want to refactor stuff, you want to get rid of it. So you need to refactor these tests in the same way that you need to refactor all your other tests. And you can also get bloat, because you can get the same behavior that's going to be covered elsewhere. And you've got testing versus monitoring. So you need to, the tests that I was writing was helping me design the infrastructure. Monitoring, make sure it stays healthy. So you need both. You need to make sure you're not repeating the same stuff. You can use your things like your Serverspec tests in your monitoring tests. But again, you need to hunt the value, make sure that the tests that you are writing provide value and they remain giving you that value over time. If they're not, throw them away. But you can do it pretty well. So example mapping. Example mapping is like really hard because the features are always different. There's no standardized way that you're doing stuff. Actually, infrastructure mapping's a lot simpler than that because you can standardize a lot of this stuff. Because I talk about context, well, that's fairly simple. If you can draw a box that's going to be one of my servers, that's one of your contexts, because what happens if I'm logged into that server? If you can draw like lines between boxes, then that's routing. So what are your routing rules? What applications are you going to install on it? What operating systems, what files, blah, blah, blah. You can create a checklist and you can very, very quickly go through this sort of stuff. So as an example, we created an immutable infrastructure architecture for a client, which runs up in AWS. It takes 20 minutes, yay to us. It's multiple servers, multiple availability zones, all that sort of stuff. So it's all like fault tolerant and all that sort of jazz. We example mapped the hell out of that in under an hour. Obviously, we tweaked it down the line, but we were able to map out the infrastructure, what we wanted, in about an hour. So Serverspec needs to know which servers you're going to run the tests on for a given context. So by default, you actually set like these are the hosts and things like that. But if you dynamically generate your inventory, that means that you can run the same tests in multiple environments. So you might have web server tests and database tests. You might run those both on your local machine. And actually, you should co-locate all your tests with your config. You suck at timing, mate. You're not a timing Nazi. Okay, I'm nearly done, and I'm coming in about on time. So when I think about testing the infrastructure that I'm writing, I'm thinking about describing the behavior that I'm expecting the infrastructure to do over a particular configuration. And I want to use rules and examples to do that. Benefit of that is it then supports refactoring. So if I want to change the infrastructure, so long as it's still meeting the same rules and examples, then those tests should keep working. You don't want to repeat yourself. So the thing that I didn't put in that testing triangle was the fact that actually it's only one part of the puzzle, because you've got your unit tests, you've got your other integration tests, you've got your end-to-end tests, you've got your smoke tests. They all live as one glorious whole. And you need to think about it all the same. And that's one of the sort of core parts of DevOps to me, is that your developers and operations, you're all working together, you're talking to each other, so you know, do I have the confidence so that I don't even need to push a button to release it to production, I can just check it in. Because if it ain't going to work, I'm going to find about it as quickly as possible. So as part of that, I think, keep the goal in mind. You want to think about what the target system you're actually developing is. You want to write the appropriate tests for it. You want to think about the steps of how you're going to get there and how you're going to demonstrate progress. And realize that, I've already said that. So you want to hunt the value. Prune your test suites. Get rid of stuff that is no longer adding value. So test driving your infrastructure can help with the design, but you do still need monitoring. You need to make sure it stays healthy. You can incorporate your tests into your monitoring, and you should build into your monitoring early. But like I said, that's another talk. Thank you very much. That's me! I was going to put a picture of a koala in here somewhere. That one's me. I was going to put a picture of a koala, but I couldn't work out how to do it. Any questions?
So for organizations that are not on DevOps, how would you recommend to use this to get a starting point to get towards DevOps?
So the question was, in case anyone didn't hear it, for organizations that aren't doing DevOps, how can we start using this to move towards that sort of thing? Number one, I'm presuming you've got a developer operations massive brick wall down the middle. I'd start by going and talking to the ops people, getting to know them. If you're doing things like developing containers, because that makes their life easier, then you can just do it. And then you can just start showing them that you've done it. And then you can start bringing them into the fold. That's sort of my approach.
One question is the infrastructure testing will be only working on Docker or will be working on any infrastructure?
Yes, so my example was, so if I get your question correctly, it's, does this approach only work if you're using Docker, or can you apply it to any infrastructure? Or, is that correct? Right, okay. So, yes, earlier on, so the DevOps movement, it was sort of brought about by the cloud and the fact that people like Netflix and things like that were spinning up massive numbers of machines that were, you literally could not manage them in a traditional manner. But the principles that that's created and the things like Serverspec can definitely be used on any sort of infrastructure. So Serverspec isn't Docker specific, it's not cloud specific. Like I say, it's got bits, and I can show you how it all works under the hood. But ultimately, if you can get a log on to a machine, you can run Serverspec tests. Whether that machine is a virtual machine, physical machine, Docker container, blah, 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 blah.
So you mentioned that you have AWS integration, that you're able to shoot the cow once it's finished. Have you seen the impact of how doing those processes affects your budget or how much you spend money on your infrastructure? And then if you see the correlation, how do you justify this cost that gets generated by these tests?
Yep. So with the client that I mentioned previously, the cost visibilities weren't, or the cost wasn't as visible as we would have liked. So I would have liked to have run those sorts of experiments to be able to say, this is how much we're saving, or this is actually how much more it's costing you. Is it worth it? All that sort of stuff. But what it did do was it entirely empowered the team. So the situation that that particular client was in previously was they had Snowflake servers. They had a development machine. So they were in AWS already, but they had a development machine. They had a test machine. They had multiple production machines, but they only ever used one at once, and they're not really quite sure whether any of them, and in fact, any of them were the same or consistent. There was an example that apparently they tried, so before we arrived, they tried to upgrade their version of Java, and it brought their production system down for 3 days, something like that. And 2-3 days equals shitload of cash. Since we've gone in, sprinkled the DevOps magic, we do the whole blue-green deployment and all that sort of jazz. We've had a few releases that went wrong. We flicked a switch and it went right again. We were able to investigate those failures, switch forward, switch back. We were able to, we can develop or we can test multiple environments in parallel, 4 or 5. So the actual empowerment that it gave the team and the ability to release quality software were the effects. Did we measure them? Probably not as effectively as we could or should have, but I was too busy writing code and going, ooh, shiny tools.
What would be your approach on writing end-to-end tests? For example, you mentioned Docker containerization. So do you just think about the application itself, or do you set up and initialize all of the database and the data within it? Or do you set up a brand new system every time you test?
Wow, that's a whole new talk. So we're talking like right at the top of the triangle. I was going to put koala up there, but I couldn't work out the best one. I like koalas, by the way. So our general approach, if we can, is number one, we probably wouldn't use Serverspec. We'd do something completely different. But if we can have immutable infrastructure, if we have Docker containers, we would look at the problem. We would look at the problem, what are we trying to solve, why are we wanting to do those end-to-end tests? So one, we'd have very few of them, because we were just wanting to check that the bits hang together. What scenarios are we testing? So we might need to test those in certain situations. Do I just want to check that all the bits hang together? Might be able to do that on multiple Docker containers running in a single machine. Or am I wanting to test that they all work together in my production-like environment? So I'd have to spin up a whole production-like environment and run my tests against it. We'd use it, what I'm saying is we'd use a variety of techniques. Yes, if we can spin up the brand new database and run our tests against it, awesome. If we can't, we'd try and work around it. But yeah, feel free to come and grab me and we can chat more, because that's like a massive topic in itself. I think
we're, yep. All right, thanks, Tim. Cheers. So we'll give it another